We are going to learn about RS Latch in this video. So you have to know what RS means. R means reset and S means set. And then you have to know what reset set latch means. It's only a small flip-flop, a very basic flip-flop that helps you to understand how sequential circuits work. Okay, so we are starting with RS latch. Instead of drawing the logic circuits and all, I'm going to teach you how RS latch is used and the terms that are associated with the RS latch. Okay, so that's it. So here we have the block, the RS latch block. Okay, inside this, consider there is a circuit that is working such that it takes two inputs, R and S. R is reset input, S is set input, and then gives out the Q, okay, the intended input and the Q bar. Okay, so why do we need Q and Q bar? That's a great question. Okay, so I have already told you in a flip-flop there is called something called feedback. Okay, the output is fed back into the system to come up with the correct output. Okay, so to reinforce the current output, the previous state of the output. Okay, for example, in the last video we talked about it like Q of n, sorry, F of n. Yeah, we use the letter F. F of n will be depending on F of n minus 1. Okay, but there is a practical problem. Okay, there is a practical problem. If we try to send Q, okay, so let's say there is a block circuit. Okay, let's name it as X. It's some block circuit that uses feedback condition. Okay, and it takes some two inputs A and B, and Q is the output, and Q is fed back into the system. Okay, Q is fed back into the system. Now this creates a small problem. Okay, this creates a small problem. The circuit will not be stable. It will not be stable. Why? Whenever A and B are changing, okay, Q will have to be responding to that. When it has to respond to that, then Q changes here also. When it's fed back, it changes here also. So the real output changes a little bit. It will create a paradox. Okay, it will create a paradox. It will create instability. So that's why in RS latch, okay, in RS latch, we use the opposites. We use the opposites to reinforce stable outputs. We use the opposites to reinforce the stable outputs. That's why the desired output is Q and the opposite of Q is also created in the process. Okay, we are going to learn how they are fed back. Okay, how they are fed back in the next few videos. But for now, just remember R and S are the inputs. Q and Q bar. Okay, instead of Q dash, let me use Q bar. That will be easier for us to understand. So Q bar as the outputs, and somehow Q and Q bar are fed back into the system. Okay, somehow Q and Q bar are fed back into the system so that they have specific reinforced stable values. Okay, now we can move on to how this is used. The use case for RS latch. Let's talk about an alarm. Okay, let's talk about an alarm. Okay, since we are talking about time-based outputs and inputs, I'm going to come up with the Q previous term and then the Q now term. Q now term. This is Q, okay, this is the Q, okay, this is the Q, but it has two states. When at a specific moment of time, it is Q now, okay, at a specific moment of time, it's Q now. Right before Q now, it's Q previous. Right before Q now, it's Q previous. So, for example, in an alarm, normally the alarm won't buzz. Okay, it won't make a sound. It's silent. Okay, so let's say silent is the 0. And when it is buzzing, let's say it as 1. Let's keep it as 1. Okay, let's keep it as 1. That's it. So this is the Q output. Okay, and Q previous is the moment right before Q now. That's the understanding that you should have. That's it. Now, okay, now there are two inputs, right? We have reset input and then the set input. When you are resetting, what we expect the alarm to do is, if the alarm is buzzing, okay, when the alarm is buzzing, when I reset, okay, when I reset, the alarm should stop buzzing. It should become silent. Okay, when we are setting, or tripping the alarm, okay, let's say there is a sensor or there is a tripping wire, something like that. Okay, when an intruder trips the alarm should be silent first, but at the moment when the intruder trips the alarm should start buzzing or making noise. Okay, so when you are setting the state of Q, okay, Q previous is normally 0. Then when set happens, Q now becomes 1. Similarly, when resetting, Q previous is normally 1. It means it was already making noise and now someone has to stop this annoying noise. So they reset the button, they press the reset button, and Q now will become 0. When reset is equals to 1, okay, when we are resetting, we will make sure that the set is equals to 0. And when the alarm is going to be set, we know the reset button is not going to be pressed. So reset is equals to 0. Okay, this is what happens. Q previous to Q now, there is a change. Q previous to Q now, there is a change. This is the same output Q. Okay, it's the same term. Same term Q. Okay, Q bar has nothing to do here for now. Okay, for now, Q bar has nothing to do here because we are not studying what's happening inside. We are just talking about the surface level application. Okay, surface level application. And this application, Q previous and Q now only changes based on reset and set. Okay, reset and set. But when set is equals to 0 and reset is equals to 0, when set is equals to 0 and reset is equals to 0, nothing happens to the system, right? Nothing happens to the system. The alarm will keep buzzing if it was buzzing, and the alarm will keep being silent if it was being silent. Okay, so if Q previous is equals to 1, then Q now will be equals to 1. If Q previous was equals to 0, well, Q now will also be equals to 0 because there is no change when set and reset are equal. Okay, so now you will have the question. Well, Priyadarshan, what if Q previous was 0 here already? Well, then if the alarm is not, it's not buzzing, it's silent, and you press the reset button, does anything happen to that alarm? No, nothing happens. It just keeps being 0. It just keeps being silent. It just keeps being silent. So that is what happens here. That's the idea. When you are resetting, only if it was making sound, it has to become silent. That's the memory part here. Q previous is stored. Q previous is stored in RS Latch. Similarly here also. What if Q previous was already making sound? Q previous is equals to 1. What if another intruder comes in and they trip the wire again, or they trigger the sensor again? Well, nothing changes. The alarm will keep making sound. That's it. Okay, that's why it knows what was happening earlier. But if it was not buzzing earlier, when the set operation happens, okay, when the set operation happens, well, then it will start buzzing. Similarly, if the alarm was already buzzing and you reset the alarm, then it will stop buzzing and become silent. Okay, if you do not do anything, it will keep being what it was earlier. Okay, now there are only 3 combinations, input combination, because we have 2 inputs, reset and set. Then we should have 4 inputs, right? 4 input combinations, which should be set is equals to 1 and reset is equals to 1. Well, practically speaking, this is not possible, right? If an intruder trips the wire, at the same time, the authorized party press the reset button. That's the practical implication of this, right? That's the practical implication. But if that happens, what's the point of using an alarm, right? What's the point of using an alarm? So at the same moment, this can't happen. At the same moment, this can't happen. This should not happen. So we call this as forbidden. There are safety measures that do not allow this to happen. That's it. These are the application or use cases for RS Latch. These are the application for RS Latch. If you want to understand this using a graph, that will be way easier for you. Okay, so let me draw the graph first. So the x-axis will be time, okay, and the y-axis will be q. Okay, so we have two values for q, 1 and then 0. Okay, so I'm going to teach you by using the graph. Okay, so let me put in some time period. So let's say 1, let's say 2, let's say 3, and let's say 4. Okay, first of all, this is an alarm, right? This is an alarm system, right? So the alarm system will be first of all silent. Until an intruder comes, it will be silent. Then let's say at the first second, someone trips the alarm. Okay, someone trips the alarm. Okay, let's say someone trips the alarm. Then Q will start buzzing, which means Q is equals to 1. Okay, Q is equals to 1. Then it keeps being 1 until someone presses the R button, right? Reset button, right? Let's say at the third second only, someone presses the reset button. Okay, let's say someone presses the reset button at the third second. Then it will become silent again. That's the idea. Okay, and it will keep being silent until someone trips the alarm again. Okay, now we are going to analyze the situation. Okay, analyze the situation. How are we going to do that? Well, we know from 0 to 1, from 0 to 1, the set was also equals to 0, reset was also equals to 0. Until the second one, the first second, reset was equals to 0 and set is equals to 0. At the first second, exactly that moment, reset was equals to 0, but set was equals to 1. That's why state of the queue changed from 0 to 1. If you consider this point of time, okay, if you consider q first second as q now, okay, then q now becomes 1, where q previous, the moment exactly right before q now, was equals to 0. Okay, so for seconds means we can say q previous was somewhat 0.999999 second. That's the idea. Okay, similarly, from the first seconds to 3 seconds, there were no other inputs given. For example, I mean, what do I mean by this? Well, reset was equals to 0 and set was equals to 0. Nobody changed anything. The input did not change. Reset or set did not change. Let's say there was another intruder at the second. Let's say they are saying there was an intruder at the second. Okay, the set was again tripped. Set was equals to 1 and reset was equals to 0. Well, tell me, does this affect the RS latch? It does not. It does not. It will keep buzzing. Why? It was buzzing and it will keep buzzing because the reset button was not tripped. It was not pressed. Okay, so it will keep buzzing until the third second. Why? Someone press the reset button now. Reset is equals to 1, set is equals to 0. Now at the third second, okay, this is the first scenario and this is the second scenario. What is the second scenario? Well, q third second. If you consider this as q now, well, it becomes 0. What was q previous? Well, q previous was equals to 1. Q 2.999999 something, 9 second. That's the idea. Before this, set was equals to 0 and reset was equals to 0. But at the exact time, at the exact third second, someone reset the button. Someone press the reset button so that the alarm can keep being silent. And here, the same happens. Let's say at the fourth second, someone presses the reset button is equals to 1 and set button is equals to 0. Okay, does that change anything? No. Why? Reset button always puts the condition q is equals to 0. Reset 1 is set is equals to 0. Always put the condition as 0. Q is equals to 0. And set is equals to 1. Reset is equals to 0. Always puts q as 1. That's the idea. That is what I was trying to say. So now, if I draw the exact same Q bar graph for this, okay, for this, if I draw the Q bar graph, how will it look? Let me draw that for you. So first of all, let's put the graph. Wait, let's put the graph. So here we have time in the x-axis, and then Q bar in the Q bar in the y-axis. Okay, so here we have 0 and then 1. What happens to Q bar? Well, let me use the green. So since Q is equals to 0 from 0 to first second, first of all, let's mark the times here. 1, 2, 3, and then 4. Okay, so Q bar will look something like this. So we start with 1. Why? Because Q is equals to 0 means Q bar will be equals to 1. That's the idea. Why do we need Q bar? For feeding back into the system so that the system does not fall into an oscillating system. Like, oscillating system in the sense the states do not oscillate. Okay, they are stable. That's why we need Q bar to feed it back into the system. When Q becomes 1, Q bar becomes 0. That's the idea. Okay, when Q becomes 1, Q bar becomes 0. And it will be 0 until Q becomes 0 again. Okay, and then it will be 1 until Q becomes 1 again. Okay, that's the idea. That's it. It responds opposite to the given system. Okay, and this is all you should know. This is all you should know to understand the use case of the RS Latch. Hereafter, you can come up with the truth table, right? Hereafter, you can come up with the truth table. Why? We know how it's going to work. Okay, so we have R, we have S, okay, and then we have Q, and then we have Q bar. Okay, Q bar. So when R is equals to 0 and Q is equals to 0, Q will be following what it was in the previous moment. Q previous. This is Q now. We are talking about Q now and Q bar now. Instead of putting now, I'm just leaving it as Q and Q bar. That's it. This Q previous and Q bar I taught you because it will be easier for you to understand. That's all. Okay. But here the Q actually represents Q now. Q bar actually represents Q bar now at the moment. When R is equals to 0 and S is equals to 0, it will be the same thing it was the moment before. So we can say previous. If Q was 1, it will keep being 1. And if Q bar was 0, it will keep being 0. That's the idea. Okay. When reset is equals to 0 and set is equals to 1, Q becomes 1. So since Q is equals to 1, Q bar should be 0. Similarly, when R is equals to 1 and S is equals to 0, Q should become 0. So Q bar, not R bar, Q bar will become 1. Okay, opposite of this. Okay, opposite of this. Then we also studied if R is equals to 1 and S is equals to 1, it is not allowed. It is not allowed. It is forbidden. You can also come up with the operation, the practical implication of this. Okay, so 0, 0, no change. No change in Q now and Q previous. Q now and Q previous, which means Q now is equals to Q previous. That's the idea. And R is equals to 0, S is equals to 1. Well, it is now tripped. The alarm is tripped. Okay, the alarm is tripped, or you can say the RS latch is set. Okay, RS latch is set. Then you can say 1 and 0 means it is reset. Okay, it is reset. And then finally, R and S are all together 1. Okay, so we'll say it is invalid or forbidden. Invalid or forbidden. This is the truth table. This is the truth table. Why this becomes a little bit hard to understand, complex to understand is because we are working with Q and Q bar at the same time, Q now and Q previous. Q now and Q previous, since this is a sequential circuit and Q previous affects Q now. Similarly, we are working with Q bar and Q bar now and Q bar previous. That's the idea. So to understand this, always keep this graph in mind. Always keep this graph in mind and this comparison in mind. If you know this graph, you can do any questions related to RS Latch. Obviously not the logic gates part, but that will be covered in the next few videos. But then if you understand the scenario and the truth table, then since you are an engineer, you can build the solution for that by using gates. That's it. So keep this in mind. I will be meeting you in the next video with NOR based RS Latch. So please do not forget to watch that video also. Thank you for watching the video on Reset Set Latch Introduction. If you found this video helpful, don't forget to like, share and subscribe for more lessons. I'll meet you in the next video. Until then, keep learning and stay curious.